All right, Algebra 2, your Unit 6 review is here. Let's do this. This is what is a square root parent function? Sketch a graph. So the square root parent function is y equals square root x. Remember, the parent has no extra numbers. It's just x. So the square root has a square root of x. If you were to graph it in your calculator, square root x. Okay, you can see it starts here, goes this way. You can press Control T and get some values here. And I'm going to go up 1. So I got 0, 0, 1, 1, and then 4, 2. Those are some whole numbers. Going one direction, right? But the cube root parent function is just cube root of x. Remember, parent is only x. Cube root has a cube root. So over here, instead, square root, I'm going to do Control caret so I can get the option to make a cube root. Go to the right, hit X. Now cube root of X, this part kind of looks similar, but then it keeps going like this, and it makes that shape. So again, if we do Control T, okay, you can see we got these 3 points, and then it does that shape. So we can plot those 3 points. So it goes like this, and then it goes like this, and it's forever and forever. Okay, so you got to know these parent functions. That's what they look like. Identify the equation and the domain and range of the graph below. So if it looks like that, this is a square root of x situation. It started at 0, 0, and it ended up here. Okay, so it went right 1, and then it went up 2. Right? Now, to get the equation, we have to remember it's y equals square root of x. Now, if it's going to be right 1, then we're going to put a number here. And remember, insiders lie. So if it's right 1, we're going to put -1. And then the up 2 is going to go outside over here. +2, it does not lie. Okay. Whether you use f of x or you use y, it's got to be x minus 1 under a square root sign. +2 is after the square root sign. Very important. Okay. Now the domain, the x value here is 1. It goes forever to the left to infinity. So you could do like bracket 1, comma, infinity, parentheses, or you could just say x is greater than or equal to 1. Either one works. The range, how far down does this go? Well, this is 2, and it goes up forever. So you could say bracket 2 to infinity. Or you could just say y is greater than or equal to 2. Either one works. You don't have to write both like I do, but I'm just showing you both, okay? Now, the equation y equals square root of x is changed to 5 square root of x. Remember, a number in front, if a is greater than 1, then it is a vertical stretch. Okay, please remember, number out front, vertical stretch. The graph of square root of x is changed to square root of x plus 4. So remember, insiders lie, and it's horizontal. So that means it went left 4. That's it. Insiders is horizontal, to lie, plus usually means right, but it's left. Okay. Now we got the cube root of x. So what happens if it's changed to cube root of x plus 5 minus 2? All right, so remember, this is a lie, horizontal, and this is no lie, vertical. So which way did it move? Left 5, and then down 2. All right. All right. Now this was our 6.4, 6.5 note stuff. So let's solve number 6. If you have the same root on both sides, so cube root here, you get rid of the cube root by cubing it. So when you cube this side and you cube this side, it's going to cancel out. So really, you're just left with a equation like this. Okay. You could end solve menu 3-1, but hopefully you can solve this. You got x on both sides. You get rid of the smaller x. Get rid of the loner. Divide to get rid of the coefficient. You get 9/2, or if you hit Control Enter, you get 4.5 as your answer. Okay. All right. Down here, solve for x. So whenever you have a cube root, or any kind of root, you need to get the root by itself. So this plus 6 got to go. Minus 6, minus 6. So cube root of 2x equals 10 minus 6 is 4. And now we can get rid of that cube root by doing the opposite. Since the root or the radical is by itself, the opposite of cube root is cubed. So I cube both sides. Okay. Cube root and the cube cancel out. Now what is 4 cubed? 4 cubed is not 12. It is not 4 times 3. Please remember, if you go to your calculator, 4 caret 3 will never be 12, okay, because it's 4 times 4 times 4. Remember, cubing means times itself 3 times, right? So again, it's 64. Not done, because 2 is in front of x. We divide to get rid of a coefficient, and we get x equals 32. All right, same idea here. We want to get the radical by itself, the square root by itself. So before I can get rid of the 3 in front of it, I have to get rid of the loner, minus 2. The opposite of minus 2 is plus 2. So bring down 3, square root of x plus 6. 19 plus 2 is 21. The radical is not by itself because there's a 3 out front, so I got to divide to get rid of that coefficient. So I get square root of x plus 6 equals 21/3 is 7. Now I can get rid of the radical. The opposite of square root is square. So I take this whole thing and I square it, and then I square the other side. Cancel those out. X plus 6 equals, what's 7 squared? 49. And then how do I get rid of a plus 6? Minus 6. So x equals 43. All right. Number 9. Solve for x. X equals the square root of 2x plus 3. Identify the solution and the extraneous solution of the equation. Okay. All right, this will take a little bit. So if since the radical is by itself, the square root sign, I can get rid of the square root by squaring, and I square both sides. So now I have x squared equals 2x plus 3. Now notice, when you have a squared on one side and an x on the other side, these are never going to cancel out. This is a situation where we're going to have to do polyroots. Okay, which was what? Menu 332. But before we can do that, we need x to equal 0. Not x, but the equation needs to equal 0. Okay, so to get rid of, let's do that. All the things on the right, we're going to do the opposite. The opposite of a positive 2x is minus 2x, minus 2x. The opposite of plus 3, minus 3, minus 3. Now both of these are going to go after the x squared because they don't combine with x squared because neither of these terms are squared with an x. On the right side, everything canceled out, so now I can write 0. And on the left side, I'm going to put x squared minus 2x minus 3. Okay. Now, since it equals 0, I'm going to use menu 332. I'm going to type it into polyroots. It's going to look like this. Polyroots. I'm going to type the left side of the equation, but not equal 0. I'm going to put comma x. This is so important right here. You got to put the comma x. Okay. So let's do that. All right, menu 332. Remember, my calculator has different buttons for some reason, but you're doing menu 332. You'll get the words polyroots. You're going to type in the left side of the equation. Don't hit enter yet because you have to put comma x. Okay. And it's going to show up with our solutions. Okay. Solutions are negative 1, 3. Okay. Now, what we're going to do is we're going to plug it into the equation. Okay. I'll put in negative 1 here and negative 1 here. So negative 1 equals square root 2 times negative 1 plus 3. Let's figure out what this right side of the equation is. Square root 2 times negative 1 plus 3. Well, that gave me 1, but this is supposed to equal negative 1. Those are not equal. So x equals negative 1 is extraneous. But what about 3? So if I plug in 3 here and here in the equation, so 3 equals square root 2 times 3 plus 3. What is the square root? 2 times 3 plus 3. Positive 3. That checks out. X equals 3 is my only solution because negative 1 was extraneous. Okay. It gave me a weird thing right here. All right. That's number 9. Number 10, identify the inverse. Okay. So remember, to do inverse, f of x, step 1, turns into a y. Step 2, switch x and y. Step 3, we need to solve x and y. Solve for y, sorry. So to get rid of a square root, I'm going to square both sides. So now I have x squared equals y. And then last step, I need to switch the order and write it as an inverse. F inverse of x equals x squared. That's it. Okay, so don't remember your step. Don't remember. Please do remember. Don't forget the steps. F of x becomes y. Switch x and y. Solve for y. Write it as an inverse function. Let's do that again on a longer type of problem, number 11. On number 11, so f of x becomes y. And then we have to switch x and y. Then we need to solve for y, so we need to get rid of the loner first. The opposite of a positive 2 here is a minus 2. Please remember that goes after the x. You cannot combine things that are not the same. So we have x minus 2 equals square root of square root of y plus 4. Now remember, to get rid of a square root, we're going to have to square it. So that means this whole side, we're going to have to square it. Square root and square cancel out. So now I have x minus 2 squared equals y plus 4. And then to get y by itself, I'm going to get rid of the plus 4 by subtracting 4. This minus 4 does not combine with the minus 2. It goes afterwards. Every time it's always going afterwards. Okay? So we end up with f inverse x equals x minus 2 squared minus 4. All right, a couple more. Number 12, graph the function with restricted domain, okay? And we want to find the inverse function, okay? So we have this graph, already graphed. I'm going to find the inverse function. Now, remember, you can take this function, make a little table. What is this? -3, -2, -2, -1, -1, 2. If you want the inverse graph, you just flip it, right? -2, -3, -1, -2, 2, -1. Whoops. And that's symmetrical across the dashed y equals x line. So that's good. But it wants us to find the inverse function. So we're going to take this over here and do what we did on the last problem. So f of x becomes y. Okay, and then switch x and y. And solving for y, the opposite of -2 is +2, goes after the x. To get rid of the square, you do square root. To get rid of the +3, you subtract 3, and do not combine it, you put it after. So our inverse function is square root of x plus 2 underneath the square root minus 3 after the square root. Okay, and that matches up with our graph here. We have a square root function that went left 2, down 3. Left 2, down 3. Perfect. Last one, number 13. Okay, function cube root of x is transformed to become the graph to the right. Explain in complete sentences how the graph changed from the original function. So the original function is right here. Hello. It looks like it's moved left 4 and down 1. Now, if I just write that, that is not explaining in complete sentences. So what could I actually write? The cube root function was translated. Now, if you don't know that word, you could just say shifted 4 units to the left and 1 unit down. I'm looking at it. It goes up 1 over 1, so it hasn't been vertically stretched or compressed. It's going up to the right positively, so it has not been reflected or anything. The only transformations are shifts or translations, 4 units to the left and 1 unit down. Excuse my bad penmanship, my handwriting. And that's it for your review. So make sure you get this done and study it and be ready for your test tomorrow.